Hello everyone, good evening. So we were continuing this Keras API and we will do that. Then after, if the time will permit, then we'll see how we can do deployment in the job lab. Okay, even whatever Keras API we are discussing, we have done them. But here, I just want to tell you how we can do that. Okay, so in the last session, we had discussed about the sequential model. Yeah, and if you remember, in the artificial neural network, we had used this. Yeah, we have used this sequential model, and I told you that in case of the Keras API, we have how much? The Keras sequential model, we had the Keras functional models, we had the standard network models, and shared layered models. Yeah, as well as we had the multiple input and the multiple output models. So we'll see them one by one. We'll just discuss about them. Okay, so let's talk about the Keras sequential first. And you know that if you remember, we were using from Keras dot models import sequential, if you remember. Yeah, so we had just started to discuss this. And then if you remember, when we were specifying the model, the another was from Keras dot layers import dense. So when you use these two lines, it means we are using the sequential model. Yeah. So means here at the time of the specifying the model, you specified that you're going to use the sequential model. Okay. And obviously, so when you were defining the model, you were just like, you're writing as a sequential, if you remember. Yeah. And then you just define the layers by using the dense. So what is the meaning of that? Yeah. So here, this is the, I can say that the sequential model Keras API is a way of creating deep learning models where the instances of the class will be created sequentially. And then one by one, the layers are added to it. Okay. And this sequential model is used mostly whenever you have to develop the deep learning model in most situations. And usually you will be seeing that everybody will be using this sequential model, but it is having some limitation. And the limitation is that whenever suppose you will have multiple different input sources, then obviously you'll have to produce the multiple output destinations, isn't? Or we have to use the models that will be reusing the layers. Yeah, and sequential models lacks there. So if I just chalk it down, then I can say that it will somewhere lagging whenever you will have the multiple different input. So when I'm saying multiple different input means I'm saying that we'll be getting input from multiple sources. Obviously, according to that, we need to say this is the source 1, this is the source 2, this is the source 3. So if you are getting the input from this, then obviously when the output will be produced, it will be given back to these sources. Yeah. S1, S2, and S3. So here you have one option that you just define the different layers for each input. You just define the different layers for each input sources, and that will become very cumbersome. And that is why you can say that this is the limitation of the sequential model. Otherwise, this sequential model is really very fine to work with. Okay, so this is your sequential model, and next to this is what? That is the functional model. So that is your Keras functional models. So when it comes to this Keras model, functional model, then I can say that it is a bit more flexible than a sequential model. Yeah. So it means I can say in another way that whatever the limitation of your sequential model was there, it is compensated by the Keras functional models. All right. So that means here it basically specifically, or I can say it especially allow you to define multiple input or the multiple output model, as well as whatever multiple input models or the multiple output models you have used, they're going to share the layers. Means instead of defining the separate layers for each input sources, here these sources will be using the same layer. They will be sharing the same layer. Okay. And that's why, when it comes to the layer, it basically, define the ad hoc network graph, where the edges are what? They are the shared layers. Okay. So when it comes to this functional models, here the models are defined by creating instances of the layers and connecting them directly to each other in the pairs. So in this way, what will happen? We would have defined the model that specifies the layers to act as the input as well as to act as the output. Okay. So it means when it comes to this functional model, then first of all, you need to do what? You need to define the input. Then you need to have the connecting layers that they're going to share. And then what will happen? Obviously, you're going to create the model. Yeah. Then obviously in that case, you will be using the multiple layered perceptron. So you have seen this, isn't it? So when we're talking about this, Okay. So, whenever we talk about the sequential model, or let me explain. Let's leave it. Okay. So when you have to define the input, so here, that when it comes for the Keras functional model, you have to, unlike sequential model, you have to, or you must have to create and define a standalone input layer that will be specifying the shape of the data. Yeah, that will be specifying the shape of the data. So, like, if I have to use it, so I can write here that from Keras.layers, you're importing input. Why? Because you're going to specify this input layer separately. Yeah. Let me say that I'm just using a variable visible. And here I'm just writing input and shape equals to, say, 5,3, which is the shape of your training data, for example. So this, you can see that this input layer is taking this shape argument. And this shape is what? It is the tuple. How you come to know? Because it is in the round bracket, which indicates the dimension of the input data. If you're giving it 5,3, so this is what? This is the 2-dimension. But you know that in the multi-layered perceptron, you may have the 1-dimensional data. So in that case, what will happen will be just is having the shape of the mini batches. Yeah. So whatever shape will have, that will be the size of the mini batch data. So here, either we can mention in this way, or if that will be for the multi-layered perceptron, then you have to use always the hanging last dimension. Hanging last dimension means, for example, if I mention here 2 comma, yeah. So 2 comma means, since it's a batch size, and batch size is what? You always written just like a 32 and all. So that's why we'll be just writing a 2 comma, because we are going to give the dimension for the multi-layered perceptron. Or you can do one thing, that if you don't understand it, you can just give the 2-dimension feature, where say that in your training data, you have the 40 rows and 3 columns. So here this shape will become 40, 3. So whichever you understand, you can do in that way. Now, you know that you need to create the layer. Yeah, we will have the layers. And as I told you that in case of the Keras function model, the layers are connected pairwise. So pairwise means what? We have done this. Then obviously you'll have to import another thing. And that is what? That is from Keras.layers. We to import dense. Although it should also be layers. Yeah. So if you want to connect them into pairwise, so what will happen? Say that this is my hidden layer 1. So I'll be just writing it as hidden. Okay. And here I'm telling that there's a dense 2. So how many neurons we have taken? We have taken 2 neurons. in the dense, and then I just mentioned here it's visible. So you see, we have made a pair. This is my input layer, and this is my first hidden layer, and we have just connected them within as a pair. So in this way, what happens? We just connect the layers pairwise. Means if you will have the another hidden layer, say that this hidden one, then obviously this hidden one will be what? Again, it will be say dense 2, let's say that 2 or 5, and then you'll be writing here hidden. So in this way, we just do the pairwise connection. We just have the connecting layer. Yeah. Okay. Now, so we have done how the input is defined, how the connecting layer is that. If you have to define the, if you have to create the model, if you have to create the model, then you need to define the model and how you will be defining the model. So obviously, again, you need to import another library. So how you do that? From keras.import model. Oh, my bad. It should be keras.model import model. If you remember, isn't? And then what we were doing? We were just building the model. So model equals to model, isn't? And then here we were specifying what is our input layer and what is our output layer. So in this case, our input layer is what? Visible. And output layer is what? It is the hidden, where we have just defined. Or since here, if you have taken the 2 layer of hidden, so this last layer will become our output. Yeah, if you remember in the pre-trained model, let me show you. You see? So you're just defining the model, and you have the input and you have the output. And how you did that? You just imported the from Keras. You see, from the keras.models, you have imported the model, and then you have loaded it. So whenever you'll be creating the model, you need to define your input and the output. As I've told you that we have already done each and everything. Now just specifying that how and what is the purpose of each and everything. Okay. So here again, like we have just defined the model equals to model, input equals to visible, and output equals to hidden one. Okay. Now so these are the different way, these are the different steps through which you just first define the input, then you connect the layer, and then you create the model. And the last thing is what? It is the multi-layered perceptron. So that means here you're going to build the artificial neural network. Okay. So this is the standard network model where what is there? Between the input and the output, you would have created a network of multiple hidden layers. And the entire will be called as what? Multi-layered perceptron or fully connected network. Yeah. And you have seen them. You have seen them. So say that, let me write here. Like, so I'll just combine and write here. Or in the Jupyter, it will be more clear. So what exactly we have done? So we have just used these libraries, like from Keras dot model, we were importing the model. It was just to create your model, and then after from Keras dot layers, we had imported the input, and then after from Keras dot layers, we've imported dense, and then you see these were the things that we have done. Yeah. And then what we have done. So if I show you this multiple layered perceptron, so here also you see, this is the where we have just connected with the pair. And this is what? This is the multi-layered perceptron. You see? So this is where we have created the network where in the, although we have only one hidden layer, which will have the 100 nodes. And you see it is paired with what? It is paired with your input data. Yeah. Now, so we have used this kind of the multi-layered perceptron. So either you just use directly the sequential model, or you can use you can just define them in terms of the input layer first, then you'll be pairing it with the connecting layers. So here, if you have to do that, then how can you do that? So obviously, as we have defined that, say, visual one variable we have taken, and there, let's say that we are defining input, it will be capital, input, and then the shape is equals to 10 comma. Yeah, shape equals to 10 comma So in this way, we have defined the input layer. Now, let's talk about the first hidden layer. So how we were defining them? So hidden equals to, you just use the dense layer, so dense, and then after, here you just define 10, means the neurons will be 10, and the activation function that you took, it was, say, ReLU. Yeah. So this is the first layer, and now we're going to make pair of it using what? The visible. So this is my first pairwise connected layer. Now let me show the hidden one. In this hidden one, let's say that we're using the same thing, but instead of say here, let's say that we are using 20 neurons in the hidden layer, second hidden layer, and the activation function again you are using the ReLU. And now you know that it will be paired with what? It will be paired with the hidden. Then suppose that you're just using the hidden 2. And hidden 2 equals to, again you are taking this and say, let it be same, only this will be changed and it will become hidden 1. Isn't? And then after, what you are defining, you are just defining the output. So what is in the output layer? In this output layer, you will have what? Dense, and say that in the output layer we have only one neuron, and the activation function you use sigmoid. Okay, then obviously this output layer is going to be paired with what? Your hidden 2. Yeah. So this is your hidden layer, and then obviously you are going to create the model. And how you'll be creating the model? The model will be created as model equals to model, and then after, you have to specify the two input. So one is what? Input, and this input will be having what? It will be the visible, because that was your input layer. And what is your output layer? So that is the output. Here, comma, outputs equals to output. Yeah. So in this way, you have just created the model. Now, friends, if you want to create the ad hoc networks and all, so this is the standard network, and for the ad hoc networks and all, you may have the convolution neural network or the recurrent neural network. So these are the other networks that you can create. All right. And in this way, you can connect your layers pairwise. And if you have to share, then how you can share? So if you remember, guys, if I show you the convolution neural network, even if you know in the convolution neural network what happens. In our example, we had taken 9 by 9, we performed the ReLU, we performed the pooling, yeah, and this here we got 4 by 4, isn't everyone? And you know, for another repetition when you had started the convolution, this 4 by 4 was given, isn't? Let me show you. So you see here that you see, this is my first convolution. Here we got 13. We got 13, and you know, this 13 was shared by the second convolution layer. Yeah, and after pooling, we got 5. And this 5 was shared to the next convolution. So means here what you are doing, you are resharing the layers. You are resharing the layers from this output source. It was given as an input to the another source. So guys, whatever we have done, that we have done now, I was just explaining you that how the APIs are working. Okay, how the APIs were working. So this is all about the Keras API. If you have any question, then you can ask me. Yeah, everyone. If you have any question, then you please ask me. All right. So friends, now let's do one thing. We'll just see how the deployment in the job lib is done. How the deployment in the job lib is done. And friends, one more thing. Okay, everyone. So let me show you. This was your syllabus. So here, one second, guys. Okay, friends. So, you know, if I see here, this we had done. Okay, that was not there. Yeah. This we had done. This we had done. This machine learning primer, when we were discussing, we had done each and everything. Okay. Then here we had seen the practical reading the offline data set using NumPy. We have seen about the reading the offline data set using Pandas. How the online data set is used, I'll show you, then you'll come to know that you are already knowing it. But still, I'll cover this, no issue. Yeah. We have already covered this thing. We have already covered this data visualization. Then pertaining to all the linear logistic regression, KNN, knife-based decision tree. Even we had covered the SVM also, although that was not in your syllabus, but still we had covered it. And not only this, we had covered the ensemble learning also, the bagging, boosting, and stacking. That is also not in your syllabus, but we had done it. Then after, we just done the clustering also. Whatever data cleansing we had to do, we had done. We had normalized the data. We had done the binning, that is binarization. We had done the missing values treatment. We had done with the typecasting and all. Then after, we have done about the feature selection. Do you remember? We just find out, we just use the best feature select method using chi-square, as well as we have just used the extra tree classifier. And then we had done the principal component analysis also. So we have performed this. Then here, we had evaluated the machine learning algorithm. We had split them into train and test. We had seen the k-fold cross validation. But after that, these things are not covered. I understand these things are not covered. And when we had covered the classification and regression, I talked about the ROC curve. I talked about the R2 square for the relay regression. I talked about the mean squared error. I talked about the confusion matrix and the classification report. And if you remember, in case of SVM, we have taken the logarithmic loss. Then we have done with the spot checking. I tell you how. When you're working on the project, I told you that whenever you have to work with whenever you work on the project, you need to select the different models so that you can get the best model. So what is the option you can do? One or two model you can take from the linear, like say in case of classification, it will be logistic regression or the LDA. You can take the non-linear model, the KNN, SVM, decision tree, and knife base, and you can use the ensemble methods. You can pick one or two models from each, and then you just build your model. And whichever will be doing best, it will be your finalized. In this way, it will just clear your dilemma that from where you have to start with. So we have done this. After that, we have done the deep learning primers. Okay, and each and everything we had discussed. What is the activation function, neural network layers, gradient descent, each and everything we had discussed. Then we just talked about this. We have seen the MNIST data. We have seen the single perceptron where that is a simple neural network, and we saw that it is having the incapability to deal with the non-linear problem. So we have done each and everything. Then after, we just went into the computer vision. We saw how the object is detected. Yeah, what is the convolution layer? And how do we do image classification? Yeah, these things we have already done. Okay, then we talk about the convolution neural network architecture. Yeah. Okay, and we have implemented this convolution neural network. Then today we had covered this Keras API. Yeah, this Keras API, today we have covered. Now we have not summarized this. Yeah, we have not summarized this, so we can say that the module 20 is left, as well as you have these two parts are left. And even you see in your syllabus, there was no the deployment part. There were no deployment part, but still I will tell you, no issue at all. I will tell you. And as I promised that I will just cover the random forest also. I will just cover the random forest also and will just summarize it. So friends, what is my target? To be very frank, within 3 classes, I'm just going to cover it. Okay. Within 3 classes, I'm going to cover it so that I can put the focus on the project, and whatever doubt you will have for next 2 or 3 classes, we can discuss the doubt. So I'm just sharing this file to you guys. You just have a look in your free time and see whatever you have. I have told you. If you find out that anything has not been done and it is shown in the red color, we can discuss. We can discuss, and if it will not have been covered, then I will surely discuss them in the class. But according to me, whatever I have specified in the red color, that has already been covered in the class. But still, you just go through with it, and if you think any topic that is not been covered and it is shown in the red color, you can tell me. And if it is true, then obviously we are going to cover it. Okay, dear? So I'm again sharing this syllabus. All right, please have a look on it. Now, friends, so friends, I have shared this file into the group. You can refer it. Hello, Parush.
Yes, sir.
Parush, you have applied for the both course, the
No, sir.
AI
No,
and
sir.
ML.
No, sir. No, sir. I was mistakenly joined that class.
Sorry.
Sir, I was mistakenly joined that class.
No, you have attended the previous classes also.
No, sir. I was not. I was trying to attend the AI lecture. That's why.
No, that's why I'm telling you, because you are in the ML class, no?
Yes, sir. But today only, and it was by
No, I have
mistake.
seen you in the previous classes also.
You've seen me,
Hmm?
but no, no, sir. I didn't apply for ML2.
Okay. So, friends, so let me share my screen now. So today I'll just show you the job deployment. Okay. I thought that you are in the AI and ML both. Okay. So friends, if you remember, can anyone tell me when we were deploying the model using the Python Flask, then how we were doing that? Everyone, if you remember, when we were doing the deployment through Python Flask, basically, first of all, why do we do this deployment and what exactly we are doing? So basically, we are saving the model and we are loading the model. Okay, we are saving the model and loading the model, because, and here I tell you one more thing, that saving the model means you are doing serialization, and the loading the model means you are doing the deserialization. So why we save the model? Why do we do that? Because You know, until and unless you will not be saving them, what will happen when you will be porting your model into some another system, then you will just have to again run all the code. So here, serialization and deserialization. So if you will not be saving the model, what will happen? Each step will again needs to be run. Okay. So how you were saving your model? You're just doing dump, isn't? Pickle dot dump you're writing, and whatever model you have specified. In our case, if you remember, we had done the classifier equals to, say a random forest regressor, isn't? And then you just train this model on the train data. Okay, so this is the model which are trained on this train data, and before that, I think that you have done each and everything. So now here you'll be using pickle.dump, and if I remember what you were doing, first of all, you're just writing the name of the model. In this case, it was what? It was the classifier, and you are writing that, say you are opening this in the form of the, say that you just dump them into model.pickle by opening them into the write mode. Yeah. So this is how you just save your model in the pickle, and you can dump if you have to dump in the job lib. Same thing will be there, but instead of this pickle, you need to use job. So joblib.dump, each and everything will be there. Only this, instead of this pkl, it will become joblib. Yeah. So it means what? Now we have saved our model in either the pickle or in the joblib. And what is the meaning of that? If you will have this model, if you will have this file, then you will not need to run your model again. You will directly be using this to predict on your tested data. Okay, next. So now what you do, you just load it into the app.py. So if I show you the code now, everything will be same. So just for the deployment purpose, what you will be doing, say that you are doing using the I'll just start with the joblib first. So first of all, you'll be creating a static folder, and in this static folder there will be the css, and in the css you'll be writing the css file, and that will be just to just to show, just to give the presentation part. And then you had what? You had the templates folder. In this templates, you'll be keeping the index.html. And this index.html will be what? It will be having the input fields where you can give the input value for the prediction. And you see, there will be one place where the output will appear. Here, the output will appear, and this is prediction underscore text. Next, let me open the spider. So friends, in the ML batch, I had just shown this. You see, the same data we are taking, the data that we have taken, it is what? It is the iris data. So, we have then gone with the data pre-processing. We just build the model, and you see, we're dumping them into the joblib. And we had just given the name of the model that was joblib, and it was open in the written mode.
सर तो इसमें वो सारा प्रोसेस करेंगे जो मॉडल बिल्ड से पहले करते हैं।
हाँ देखो, एक्चुअली में सुमित, पर्पस क्या होता है मेरी बात समझना। देखो, अगर मान लो ये मुझे दूसरे सिस्टम पे रन करना है, जैसे सपोज करो मैंने मॉडल यहाँ पे बनाया, अब मुझे तुम्हारे सिस्टम पे रन करना है, तो मैं कैसे रन करूंगा? मैं एक ऑप्शन में पास क्या है कि मैं सीधे ये कोड लेके जाऊंगा और तुम्हारे स्पाइडर पे रन कर दूंगा। दूसरा ऑप्शन क्या है मेरे पास कि मैं इसको जस्ट पिकल या जॉबलिब में कन्वर्ट कर दूं। तो उसका मतलब क्या होगा? अगेन मुझे ना तो डेटा को रीड करना पड़ेगा, ना तो उसे प्री प्रोसेस करना पड़ेगा, ना तो मुझे ट्रेन करना पड़ेगा। बिकॉज इफ यू रिमेंबर when we were working with the large data set, it was taking some time, na Sumit?
Yes, sir.
Just to save that time, what we can do, we can save this model, isn't it? So we have saved this in the joblib. Okay, we just have saved this model in the joblib. Now we have to make sure that this joblib file should be in the same folder where your model.py is residing, where your app.py is there. So you see, your joblib file is here. And if I show you this app.py, can you see the same thing we have done? Sumit, do you remember this code?
Yes, sir.
Yeah. So here you see.
सर एक और क्वेश्चन था सर, इसमें डेटा विजुअलाइजेशन का तो कोई सेंस नहीं बनता ना?
None. See, देखो, what is the purpose of data visualization? The purpose of data visualization is just to know about your data so that you can decide somewhere on the basis of your experience that what model will be suitable for this data. Isn't it? And do we need to do any countermeasure or not? So you see here what you have done. You have load the model, isn't it? You have just load the model. Okay.
Yes, sir.
So you have just load the model here. And everything is same. Everything is same. Only the thing is that instead of the Flask, you are importing the Joblet. Okay. Now, even if I run this, it's the same thing. Same thing. And it is predicting. So you have seen that whatever things were there, everything was same. But instead of the Flask, we have just dumped it in the Joblet. Okay. Now I think somebody was having some question yesterday related to deployment. Can anyone tell me what was that question? Anyone? सुमित, ये आपका क्वेश्चन तो नहीं था?
सर कैन यू रिपीट, मेरा वॉइस कट गया था.
मैंने पूछा था किसी का कोई क्वेश्चन था डिप्लॉयमेंट से रिलेटेड कल.
यस सर, इट वाज माय क्वेश्चन.
क्या क्वेश्चन था सुमित?
सर यही कि मतलब डिप्लॉयमेंट करते कैसे हैं. वो HTML फाइल सर, बेसिकली वो HTML फाइल बिल्ड करने में मेरे को मतलब प्रॉब्लम आ रहा था. मेरे को HTML आता नहीं सर. मैं
आपको बताता हूँ. तो ये इसलिए मैं पूछा था क्वेश्चन क्या समझो. सी सपोज आई जस्ट, मेरा स्पाइडर कहाँ गया? मैंने क्लोज तो नहीं कर दिया. मैंने स्पाइडर क्लोज कर दिया, कोई इश्यू नहीं. See, what is the HTML? I tell you. Basically, HTML is the tag-based language. Tag-based means everything is written inside a tag. Everything is written inside the angular bracket. Okay. So, आपको सुमित कुछ भी नहीं करना है. You just have to use this entire folder and you have to do a little bit change in the HTML file. And I tell you how you have to do. Let me tell you. Suppose right now you are using iris data, isn't Sumit?
Yes, sir.
So you had what was the column? You had the input column sepal length, sepal width, petal length, petal width. How many columns you have?
4.
4. Suppose that you have 5 columns. But since we have deployed this model according to this data, so obviously somewhere in the HTML, there will be field that will be taking only 4 input.
Yes, sir.
Yeah. But now you have to modify it. Otherwise, everything will remain same. And how you will do that? Just read that HTML file first. This is the HTML file. Forget about each and everything. You see, you can change this iris to whatever problem you have. You can do now here only. You see? Everything will remain same, just you have to change the name of field. And if you have the 5 field, so what you will do, you will just increase this line again. You'll just add one more line of it. And you have to change the name according to the name of your field. That's it. For example, what was your project?
So it was the regression.
Regression. And I think global sales now?
Yeah, wiki sales.
So suppose you're talking about the any platform. So what will happen here? It will become name equals to platform. The placeholder equals to platform. Yeah. Here again, the name equals to something else. Then it will become here. That will become here. And how many input fields you had in your project, Sumit?
Uh, sir, around uh, eight, 8 or 9, I think.
Yeah.
सर मतलब इसमें अगर हम वो टेक्स्ट डेटा डालेंगे तो उसको भी वो रीड कर लेगा ना?
किसको?
जैसे पब्लिशर में था टेक्स्ट डेटा, जॉनर में था टेक्स्ट
हाँ
डेटा।
हाँ हाँ हाँ, देखो जो भी डेटा अगर आप देखो एक्चुअली में फिर वो क्या कहते हैं उसमें नहीं होगा ना, उसमें आप ऑप्शन फिर दोगे ना उस हिसाब से और वो ले लेगा, क्योंकि एट द एंड योर मॉडल इज डूइंग व्हाट it is actually when it was taking to prediction, it will be doing in the form of label encoding, if you remember.
Yes sir, but I have chosen for one hot encoding.
No issue
I've
at all.
done one hot.
Model will be taking one hot encoded, but here you will be giving the input as a text data. I show you. Uh, See, for example, you see, I think that will be in this documentation, not this one. Might be. Let me check. You see, Sumit, what kind of output we are giving? What kind of input we are giving?
Yes sir, it is text data.
Yeah, and still, what it is doing? It is doing prediction. Getting my point?
Yes sir.
Okay. So friends, if you have any question, then you can ask me. Otherwise, we'll just stop here and we'll just from tomorrow onwards, we'll just cover each and everything, whatever we have left with. Yeah. It was machine learning, no? And friends, I'll be happy just to discuss the doubt if you will have any, or if you have any.
Sir, where exactly do we implement this Keras API?
Sorry, beta.
Like, where exactly do we implement this Keras API? Like, we add the layers to layers, but how exactly do we implement this?
We have already implemented. We have already implemented, if you remember, in the convolution neural network, multi-layered perceptron, we had already discussed. If you remember, artificial neural network when we were discussing. Actually, you know, whatever we have done, I just wanted to tell you what is the purpose of each and every layers and how we are doing that and what are the different way through which we can do. Getting my point? Whatever I have shown to you, you see, you just see whatever deep learning file I have shared to you, be it the convolution neural network or the artificial neural network. That we have already done. We have not learned anything new today in terms of the Keras API. I was just introducing those APIs, whatever we have done already. Okay, Khushbu. For example, I show you again. You see, we have already imported these models, sequential, dense, and all. And can you see? So we have already done this. We have already done this. Actually, I was just discussing, since that was in your slip later on, after doing implementation of it, that was in your syllabus. So I just discussed and I just explained whatever we have done so far in the deep learning. Okay, dear?
Okay.
Yeah. So friends, any other question? All right then, so we'll just stop here. And now from tomorrow onwards, whatever we are left with, we'll just try to cover it. And again, I'm reminding you, please go through with the syllabus. If you think that something is not covered and it was highlighted with red, do let me know. We will discuss that whether it was covered or not. And if it is true so, then we will cover it, no issue at all. Okay, everyone. So let's stop here. Till then, thank you, everyone. Thank you so much. Bye-bye. Take care.
Thank you, sir.